Hello guys, welcome back to our channel. So today we'll discuss about top 50 interview questions, question and answers on high temperature materials. Uh, so the first question would be like what is high temperature material? So material that retains the strength, stiffness and environmental resistance at elevated temperature, typically greater than zero point 0.4 of melting temperature of the material. We call it as high temperature materials. So why do these metals loses the strength at high temperature? So that's because, so what happens if you increase the temperature, the atomic mobility also increases. So that causes the dislocation, climb, diffusion and creep. So because of that, they loses the strength. At very high temperature. So what properties are critical for high temperature applications? One is creep resistance, oxidation or corrosion resistance, thermal fatigue resistance, microstructure stability. What is homologous temperature? So, so what is homologous temperature? It's a service temperature divided by melting temperature. So the creep becomes very significant, which is above zero point 0.4. So that is called homologous temperature. Why is elastic modulus decreases with temperature? Because as I said, the interatomic bonding stiffness of the interatomic bonding stiffness reduces. So hence the modulus elastic modulus in nothing but is stiffness. So which reduces with temperature. So what is thermal fatigue? Thermal fatigue, which is caused by cyclic temperature and also the induced stress, even without external loads. So this thermal fatigue is due to the temperature, cyclic temperature. Why coefficient of thermal expansion CTE matters? So because it mismatches causes the thermal stresses and interface failure. The difference between high temperature strength and creep strength. What is the difference between high temperature strength and the creep strength? The strength is it's the instantaneous load capacity, whereas the creep strength is the long-term load capacity. So that's the main difference. What is creep? Creep is a time-dependent plastic deformation under constant stress at high temperature. So there are different stages of creep. One is primary creep, secondary creep, and tertiary. Primary is called deceleration. Secondary is called steady state creep. We also call tertiary the acceleration, accelerating to failure. So we call tertiary. So which creep stages dominates the component life? The secondary creep is the most important one we consider for the component life design. So the creep mechanism, what are different creep mechanism? One is dislocation climb, diffusion creep, grind boundary slidings. So what is creep rupture strength? It's a stress causing the failure after a specified time and temperature. What is Larsen-Miller parameter? It's a time temperature parameter used to extrapolate the creep data. Why long-term creep test is impractical? Because service life may be 10 to the power of 4 to 10 to the power of 5 hours. That's why we know we don't consider the very long time creep test. What is stress relaxation? Uh, it's a reduction of stress under constant strain at high temperature. Why grain size affects the creep? Because the large grain reduces the grain boundary sliding, so that's lead to a better creep resistance. So what is creep versus fatigue interaction? It's a combined damage under thermal cycling and sustained load. So that is called the creep fatigue interactions. So the common high temperature alloys, what are the common high temperature alloys? One is nickel based superalloys, cobalt based alloys, ferritic or martensitic steel, titanium alloy at moderate moderate temperatures. These are some of the alloys we use at very high temperature applications. Why nickel-based superalloys dominate turbines? Because it has excellent creep, oxidation resistant and phase stability at high temperature. That's why we use nickel-based superalloys in turbines, gas turbines. So what is the role of gamma prime in superalloys? It provides high temperature strength via precipitating hardening. So the next question is single crystal versus crystalline plates. So single crystal eliminates the grain boundaries because it's a completely one crystal, whereas it's very superior for creep resistance. That's why we use more in blades and all. We use single crystal than polycrystals, crystalline. Why cobalt alloys are used? It's better thermal fatigue and hot corrosion resistance. And what is the limitations of titanium alloy at high temperature? So the limitation is it has a rapid oxidation and loss of strength, which is above 600 degrees centigrade. So that is a limitation of titanium alloy at high temperature. The role of ceramics in high temperature applications. It has high melting point, but it's a brittle. Brittle is one of the limitations in ceramics used, but they are using for thermal insulations. What are thermal barrier coatings? You can have heard about thermal barrier coatings. It's a ceramic coatings that reduces metal temperatures. What are the failure modes of TBC, thermal barrier coating? One is spallation, and another is oxide growth, and third one is a thermal cycling damage. Why oxidation resistance is critical? Oxidation reduces cross section and causes crack initiation. How do you design for high temperature application based on creep, fatigue, oxidation? Um, Not the room temperature strength. We are taking at very high temperature. So all this data for the designs. Why the steady state stress is not enough? Because it's a time dependent damage which dominates the life. How is creep models modeled in FEA? Using time dependent constitutive laws. What is creep fatigue interaction rule? It's a damage summation considering both the mechanisms. Why temperature gradients are dangerous? They reduce high thermal stresses. Importance of dwell time. Long dwell increases the creep damage. What is ratcheting? It's a progressive strain accumulation under cyclic loading with the mean stress. Why material data scatter is high? It's due to the microstructure sensitivity and long-term exposure effect. What is the role of manufacturing in high temperature performance? It's casting defects, grind orientation, coating quality affects the life. And next question is what safety factors are used? So at higher than room temperature due to uncertainty. Why high temperature failures are catastrophic? They often occurs without warnings. How do you validate high temperature models? Based on the correlation with creep and thermal fatigue test. So there are some standards we use. What standards are we using? We are using ASME standard, ASTM, ISO, aerospace, OEM specifications. These are some of the standards we follow while designing high temperature materials. How do coating affects the life predictions? They change the temperature, stress and oxidation behavior. The big mistakes in high temperature analysis is we should not use a room temperature property. We have to use always high temperature properties. Why transient analysis is important? Because when you do the startup and shutdown, so this causes a maximum damage. So that's why we have to use a transient analysis. What is microstructural degradation? It means the phase coarsening, carbide dissolution, the word formation, etc. It's called the microstructure degradation. So how do you explain creep to a non-engineer? How do you explain? In the sense like it's a material slowly stretches under heat over time. So there is a constant stress and there is a heat. So what happens with respect to time? It actually slowly gets elongates. What is safe life versus damage tolerant design? It's a high temperature part often follows the safe life philosophy. What is the role of inspection and monitoring? So it detects degradation before failure. Future trends in high temperature materials. In future, we can use CMC like CMCs and advanced coatings like ceramic matrix composites, advanced coatings, additive manufacturings. These are the future trends in high temperature materials. So if you say one line industry philosophy, at high temperature, time is dangerous as steel. So time is very important. As the time process like creep. Like for example, if you take any material without applying any stress, or if you take a constant stress, constant temperature, with respect to time, it actually deforms. So that's why in high temperature, the time is very important. As dangerous as stress. Okay, that's all. Uh, these are some of the few questions addressed here. So, if you want some more questions, there are so many questions on high temperature materials. If you need some more questions, please comment below. We'll make some other slides and upload it. So that would be useful for your interview preparations in corporate or entering into any PG course or doctoral courses. Okay, thank you so much. So see you in the next video. Thank you.